Cool or not? Yeah! Okay.
It is
Oh, God, it's hot and sexy. Well, I don't know if it's sexy, but anyway. Yeah, of course it's cool, but why? Why is it cool? Why is it cool?
Because it's fun.
It's fun. Okay, what else?
It's alive.
It's alive. Yeah, it's Frankenstein. It's a live environment. Yeah? That's why it's cool. What else? Why it's cool? What other reason? It's reflective. It's, what do you say about it?
Productive.
Productive. Well, the other thing I'm trying to take from you, and I think I know it's there, is because it's dynamically typed. Yeah? Okay? So that's great. That's great. Because it's an environment that is alive, that is live, it's dynamically typed, and help us to do experiments, to quickly change things, and to have immediate feedback, and that's amazing. That's really cool. But looking for senders is done statically. Why? Therefore, when we do that statically, we get more senders that we're really looking for, and we have to filter them. We have to do some work in our head that the machine could be doing. When we're looking for incrementals, it's done statically. We have the same problem. Renaming a message is done statically. So we have to we have to look for the real senders and real implementers and do that ourselves. Autocomplete in the browser is done statically. It's not good. You don't get all the real information. And so on. But Smalltalk is cool. It's cool. Is it? Because it's a live environment. And it's dynamically typed. But can we get rid of this but?
Yes, remove the flag.
Well, yeah, cool. Okay. So what if we combine live environment with dynamically type, and we get this idea of dynamic or live type information to improve our tool, okay? And to do that job that we have to do in our minds. So how does it work? Is it some changes in the VM to store type information, some changes in core classes to keep that information, and of course the tools to use that information. That's the whole idea. Some preconditions, when I thought about this, I said the VM is laughing when we are developing. It's doing almost nothing. When we are developing, the VM is, resting. So we should, use that fact. And also, if we change something, what I'm going to send, the idea is that the same image should work with a VM that takes information to get the types, or a VM that doesn't. It should be the same image should run on any VM. So, what did I do? For instance variables, I added an instance variable to class description that is called instance variable row types. That's maybe I should show this. That's an that points to an array of the size equal to the amount of instance variables you have defined, not in the class but in the whole hierarchy of change, and each element of the array points to another array. Okay? So in this case, if you have simple measure will have an array of 2 elements that will point to the types for each of the instance variables of that class. So if we inspect simple measure, we'll see here that we have an array with 2 elements that are the classes of the objects that were stored in each of the instance variables of this class. The same thing if we see, for example, schedule it only defines one instance variable, but in the hierarchy it has start and duration. So if we look at that class, we will see that it is an array of 3 elements, not only one, okay? With the type of each of the elements. I'm using type and class, if they were the same thing. And they are not, of course. And so how does this work on the VM? It's very simple. Every time that there is I modify the bytecode that assigns an object to an instance variable to get the class of the receiver, of the object that has the instance variable, and then it looks for the array in that class for the instance variable more times, and then it does this. That is very simple. If that array is nil, that's nothing. So that means that if you don't want to keep type information for a specific class, you just put nil there, and it doesn't do it. And if it's not nil, it takes the class of the object that you're assigning to that instance variable and look for a slot in that array to put that class. And this is very simple. It depends on the size of the array. It takes the element of at the index of that array. If it's equal to the class that I'm already storing in the instance variable, it means that it's already in that array. We don't have to do anything. And if it is nil, it means that we found a place for that class to put that class in that array. We put it and get out. And of course, if you get to the end of the array, nothing happens. That class is lost. It's not stored. So it's very simple. It's just that. As I said, if instance variable row types is nil, it means that you don't want to store types for that particular class. And if one of the elements, I think I didn't show it here, but if one of the elements of the array is nil also, so it's not pointing to another array, it means that you don't want to store information for that particular instance variable. Okay, so this is what I showed. What about methods? Because that's for instance variables. We have to do the same for methods, for arguments and temporaries and return types. So methods can be expanded with information with this class, additional method state. So what I did, I added these 2 instance variables to additional method state that are both variable types and return types. And it's the same idea. This is a method, so in the previous to the last literal points to the additional method state. That's something that already exists in Faro and Squid and Quiz. And you have a pointer to that array, that the first elements are the parameters, and the last elements are the temporaries that point to their arrays. And then there is another that points to the return types. So the basic structure to store type information is the same no matter if it's instance variables or arguments or whatever. And again, the chain is very simple. For example, this is to give the argument types. If you have arguments, well, it takes the argument from the stack and blah blah, looks does that for each argument, and at the end it calls the keep information types, the same as with instance variables. And yes.
What is that called?
This is every time a method gets activated. Start executed. Yeah. This is when you're setting a temporary variable. Also the same idea. We look for the temporary variable, and then finally we send the keep type information and do the same thing. And this is for the return type. Again, it's a little bit of, you have to take the information and then and keep that in that arrays. Not difficult. It's very simple.
So one question. So temporary variables that have come on each assignment.
Yes.
And arguments at method
Activation. Yeah, because you cannot change
and
arguments.
return on method exit.
And returns on method exit. That's right. Yeah. And it's very simple because the bytecodes for those things are very specific. So, what can we do with this? Yes?
When do you invalidate the information?
Well, we'll get to that. So, to see how it works on... I think it doesn't make sense to show this. This is a method, divide simple measure, that has an argument, two temporary variables. So let's inspect that. And here we can see the types for the arguments and the argument, two temporaries, and the return types. Very simple. So let's see some statistics. When you have this, what did I do? For example, I created all this type information based on the current existing objects. So when you do that, you just start having information because there are already objects in the image where you can get that information from. So one interesting thing is that you can see the number of types. What this says? It says that there are 958 instance variables that have never been assigned. This is on the image, quiz image, when I run all the tests that comes with quiz. There are 999 with one type, 341 with two types, and then we see this decreasing a lot. And suddenly we have things, weird stuff like, there's one with 270, what's this? Well, that one, let me think a little bit. No, okay, yes. So there is one instance variable, 277 different types. Yes. But one conclusion that you get from here that we all know is that polymorphism is not used that much. Do you want to know? Do you want to know? Do you want to know? I don't hear you. Well, that's who's that one? Superclass. Superclass is that one, and it's interesting because that means that I think I didn't take too much time to think it, but I think it's because we have 277 branches. Should be like that, I guess. I don't know. Yeah, or non-living class. Well, I don't know. But so what can we do? Something that we can do is we can define in this method that this model that I'm building allows you to say, okay, but let's do this. If the instance variable that you want the information from the superclass, just return always behavior. Okay? Because that's the superclass of classes. And if you do that, then it disappears. So they are involved. So it's not only that you can use the information that you get from the VM, but also you can, start defining the types of instance variable arguments or temporary variables or return types of methods in this way. And another interesting place where I had to do this is for the method class, for the message class that is implemented in object or proto object to return Well, here is another interesting statistic. All the megamorphic variables. Megamorphics is more than 10. Why? Because I use 10 as the maximum size of the array. Why 10? Because we have 10 figures. And you start seeing things that make a lot of sense. For example, look at key and association. Key and value are used polymorphically a lot. Makes a lot of sense. Meta class also makes a lot of sense. I don't know. You can start doing taking some feedback from this. We can do the same for arguments and temporaries. For example, there are like 18,000 whatever temporaries and local variables that have never been assigned. This could means also that methods that were never executed, that they are not. And well, anyway, we can see how it goes. That's right. That's one of the conclusions. It's very easy.
It looks. Can we say that it looks like polymorphic inline cache, but on the image side?
No, because polymorphic inline cache only is you use that when you're sending a message.
Yeah.
This is when you are storing an object in a variable. So with polymorphic inline cache, I was going to talk about that in a bit. Yeah, you don't get the same type of information. You don't control polymorphic inline cache. No. The idea is similar, but it's not exactly the same. So let's see some performance statistics. Those are some tests I ran. Oh, I didn't mention that I did that on the stat-VM. Okay. Why? Because that's the VM I know, and I thought that it was the simplest one to change. And well, as a result, it takes a 1.4x, but it's not that much. And the good thing is that you don't notice that when you are developing. That's the most important thing.
1.4x,
Yeah.
40% penalty.
Yes. Yeah, I thought it was more because I when I took the like a week ago, I made a mistake and I took them again, and it's not that much. It's not that much.
And that is capturing all the types of all the variables.
Yeah.
And it's just for development, because for random you can just not.
That's right. Yeah.
And size? The image size? Okay.
Size. So it's 1.47 more.
Let's go to the scene.
So if you have the array for each instance variable, for each temporary, for each argument with a size of 10, then for the same image that is 13 megs, you get 25 megs. Yes? But it still is manageable.
I mean, the correlation will be between the number of methods.
Yeah,
not
yeah.
the image size.
Oh, but no, so I don't understand your question.
Yeah, well, the image size might have something that's not strictly related with. I mean, you're creating information,
Yeah.
meta state
Yeah.
for each method. So the comparison should be between the methods, the count of methods, and the size.
And how it grows.
Exactly.
Okay, yeah, it could be better.
But that's
simple, yeah. Simple stuff. Okay, so that's about the statistics. What about tools? Well, let's start with the auto-completion, or auto-complete, or whatever we want to call it. So, as I said, when you start using this, you can get type information based on if this method was run, then you can know the type of object and the type of the instance variable. At this time, there is no type information because it's never been run. Okay? How did I do that? Print type info, and it shows you the type of the place where you are located.
That's generic.
Okay? What? Yeah.
Looks like a generic.
No, but it's not. No, I mean, I have no idea how to, that's a deal with it. So, so if I want to use auto completion because I don't have type information here, and I want to see all the messages that start with EX, it shows you extend the exponent or whatever. Yeah? Basic or how the autocomplete decides to show you those messages. That I'm not sure how it does. But if I do this and I store 1.0 in that instance variable, so now, of course, if I come here, now it says small float, whatever. So if I start, and now if I say EX, it shows me the real messages that are implemented in that class and all the superclasses and whatever. So you get real type information in a browser that is static. We have also a tool that where you can say, show me the source code with types. So, for example, I have selected that here, and it shows you, the type for each instance variable. State could be plain X, plain O, player X1, and blah, blah, blah. And all of them has a common supertype, tic-tac-toe state. The other two are ordered collections. And you can do the same for methods. Yes, you get information.
Sorry, one
and,
question. That
yes.
looks like a comment.
Yeah.
But is that a comment?
It's a comment, but if you modify it, I don't know, let's do this. Well, I lost all the type information because I haven't implemented what he just asked. And if you remove this, it's a comment, but it takes care when you change something to remove the comment or combine it. That's why here it says type info. Don't put another comment with that start with type info. Okay?
I know if you wanted it, how is that reference?
Oh, okay. Yes, I wanted to test. Oh, no, sorry. I have to, like I said, it's not implemented that yet. I have to initialize the type information for all methods. Well, just for that one. I should do that just for that one, but just for all. And now, yes. So, I don't know, this is a nice information that you get when you are programming. What else? Well, what I just showed you, you can get the types, the type info for the parameters, for a message. If you want to know the return types of hash, up, diagonal, or if you want to know, of course, the type of self, that's nice. But also, you can get the type of the return. So you can get the type of every piece of code in the method, and it's really useful. It helps a lot. It gives you a lot of information.
Hernán,
Yes.
do you have an example where very simple, basic, manual, one-type inference won't give you nothing useful except option? In this case, it gives you good information.
Yeah, I mean, well, yeah. Let me continue with the example and see if I satisfy what you are asking. So that's showing the type info. Let's see senders. I showed a little bit the other day. I think it's no. Where is it? Well, I think it's this one. Has player on. the refactor we made the other day. So as I showed the other day, let me change this one. Let's use this one. So here, if you look for senders of hash player x1, you get 5 senders. The one that is the method itself that sends the same message to state, and these are tests that send the message to the game, to tic-tac-toe. So, and if you want to know all the senders of this message to the game, then you have to start filtering that information, right? Okay, you have to say, oh, okay, but wait, this message is not being sent to the tic-tac-toe, it's sent to the state. That's the thing. If we look for type senders, then we will get only 4, because I was here with the cursor. I can do the same if I go here, type senders, and it shows you only 4, because those are the real messages sent to an instance of a tic-tac-toe. And if you come here and ask for type senders of that message, it will show you 1. Yes? Because this is the only place where that message is sent to the hierarchy of state. So you get more information. Yeah?
I was just wondering, if you have these methods and then there is a return self has played blah blah blah. If you change the code to return state yourself has played 1 and then look for the type senders of the has played 1, what would it show?
Okay.
Just
how do you want to change the method?
return state.
Yeah.
Yourself has player 1.
Yourself has player.
Yes, exactly.
Okay.
And the semantics should be the same.
Yeah, let's see, I don't know. I think it should work. It should work correctly. So, if we look for, senders to have 4, and we look for senders of this,
Like type senders.
has player is not implemented in object. Okay. Let's see what we get here. Why yourself is object? I don't know. Well, those are the things. Well, I don't know. We should look at the bytecode in this case and see. It's a quick return. Okay. Currently, on quick returns itself, it returns the class of where the method is implemented. So that's why it's answering object for this.
Yeah, that's why I was.
So there are some things that they have to be, think a little bit more in some cases. But that's why. Okay? But anyway, I mean, you can start playing and see why.
And what happens if you assign state yourself to a temporal, and then on the next line,
You should use a refactoring.
This, like this. Okay.
Extracting the temporary.
What?
Yeah, it's going to be different. It's going to show you the right information now. Yes, because now if we look for the senders of this one, it's going to show you only 1. Because now the type of T1 is exactly the states. Okay, because yourself statically says that it's object, but dynamically is the real object. So when I assign that to T1, I get the real class for the object. Yes?
So if we take this one here, let's say that we leave this information for this specific method as it is, so we're gonna change just the inner method implementation to now return an integer for whatever reason.
Who, this one?
Yeah.
That one, yes. So I'm using type implementers,
Yeah. Now
so it's only going to show me the state.
yeah.
Yeah, so what do you want to return?
Just return 42.
42 where? Here?
Instead of false, yeah.
Okay, the tests are going to fail, okay? But yeah, let's try. Wait, game type. Okay, so now,
And now let's investigate the same method as before.
yeah, let me run the test. Fails. There is a test that fails,
Yeah.
okay? And now what do you want to see? The type of
I want to see the type of the return of this method.
this method.
That one that has clear X.
True, false, small integer.
Exactly. So now that's the thing. So now you return true, false, but now it will from this point on it will never be true, false.
Yeah, of course.
Yeah,
That's why I show you the supertype is object.
Yeah. So now this question is how do you because true and false it will never happen again.
No,
Because you change the method. This one depends on the inner method.
it will happen. That's why we have true and false there. Because in some place I return false and true. I mean, I change only one implementation of that to
That's my
return false.
question. Is it when do you invalidate the
No,
whole information?
right now I don't invalidate it. That's one of the things that we have to think about.
Okay, but then if you would change all those inner methods to return 42, you can still get true.
Yeah, that's right. That's correct.
Yeah,
So I have no idea. We have to think about it. Yeah, that's something that future work. Okay. That's something that we
But
need to
this
think
is
about.
what happens with every cache.
Yeah, but
But yeah, you get wrong information. That's why you say that he's correct. Yeah,
but the question could very well be that you might want to, for example, within so you will invalidate all the information every time you run all your tests.
For example, could be. Yeah, could be.
The other thing to remember is that so when you're doing implementers and you're actually using this information to filter,
Yeah.
you are now telling me I might lose information.
Yeah, and let me show you that example. Yeah. So well, whatever. Let's see. Here. I don't know why I have behavior. So this is where the message that is sent when you want to look for the type senders. I'm not proud of it yet. Okay, it wouldn't pass the test that I take at the university. But you can see nice stuff from here. For example, if I look for senders of code provider type sender, you will get some info, but also unsure. Okay? So why is that? Is because when he was taking information, there was not enough information to give you, to deduct the type. And in this case, it's because we have never done a rename temporary in this image. So we don't have that information. And it's interesting to see, for example, this one. There are a lot of places that is not sure. And the same thing for implementers. When it's not completely sure, it shows you that it's unsure. And the same thing if, for example, selected class or meta class, if we look for the type, well, incomplete, there is no return type for workspace selected class or meta class. Yes? And if we look for implementers, I think type senders, because it could not get a common supertype, it will show you to browser, to the method in the class browser, you have all these senders. To the method, I don't know why only browser, but anyway, and then it's ensure in all those other ones. So it will show you per method the things that he can be sure and the ones that he cannot be sure. But anyway, let me continue because I'm out of time. So the rename could be typed also. So some comparisons with other techniques. Well, we talked a little bit about peak, type inference. Well, type inference doesn't cover all cases because it's static and it's slow. Annotated types, we were talking about that just today with Jan. Well, the thing with annotated types is that the programmer has to annotate the types. And, why should we do it if the computer can do it? Same idea after you get the types, but why should we do it? Let's Smalltalk do it for us. Some conclusions. Well, it's a very simple technique, and for me this is the most important conclusion. If we implement this in Smalltalk, this will put us one step ahead of any other dynamically typed language. It will not be the same as working with Python or Ruby, because they don't have the possibility to get that type information when they are programming. And we will get closer to those people that say, oh no, Smalltalk is not statically typed, but hey, come on, we have types, and we can statically, do some inference on that and those kind of things. So that's something that will, I think is going to help Smalltalk a lot from that perspective. It's not, of course, a killer app. It could be a killer feature. Other thing is, some people may think, oh no, but why should we be typing Smalltalk? This is not typing. It's not the same as what you do with Java or C#. Because the idea is not to stop you from doing stuff, but to help you to get more information. So it's not to stop, to compile or those kind of things. It's to give you more information to be able to reason about what you're investigating or doing. And a feeling I have, because I start using it, I think I have, after I start using it, is that when you start, you don't want to lose it. Because when you see code that you see, not see code, when you see code that you didn't write and you don't understand it very well, it gives you a lot of information, having the types of the variables. And as I said, type information could be used, type operation could be used on production, even though I think it doesn't make any sense because this is for tools, not for production. Future work, there are a lot of things to do. For example, I'm not storing types from variables in blocks or temporaries that are referred from blocks, nor primitives. There's some work to do for collections and to start parameterizing types, because right now it says it's a collection, it's an ordered collection or a set, but it doesn't tell you anything about the type of the elements of those collections. And of course it should be implemented in copy and not only in stack. From the image point of view, well, if you change a class, if you rename an instance variable, what do we do with the type information we already have? If we add an instance variable, or those kind of things, well, we have to think about it the same for methods. Another limitation is currently when you are debugging, because the VM is not running, well, the VM is not running the code that you are debugging, is not storing type information. What happens if a type of object is not assigned anymore to a variable? And of course, it's a lot of define. And of course, crazy idea. For example, can we optimize the method lookup with this information? I mean, why should we make the VM create the peaks if we have the information for the compiler to create the peak? I don't know. Could we get something similar to big tables? I don't know. It's something that we could use this to get uncover methods, a dynamically typed checker, whatever. A lot of things to think about, and if you want to write a thesis, let me know. I have a lot of work to do. So it's, I wrote this before he gave the check to Peter, okay? It's not that I did it in purpose, but the next steps are, well, we have to do time to work a little bit more on this. We have to finish this on quiz. That's one thing, the next step. And then after that, I think we should, start coding to other Smalltalk. And I think Pyro should be the first one. Well, thanks. don't have time for questions.